Hello, my name is Nigelargriffiths. I work in Power Systems Advanced Technology Support in Europe. In this movie we're going to look at getting started with PowerSC Trusted Firewall. Now the first thing I better say is that if you're on your networks you're using Telnet or FTP, then you have no network security whatsoever. So you should stop watching this movie now. So let's assume then you've taken those two protocols off your network and you want to make your network more secure. But one of those features you can use is this Trusted Firewall. It comes as part of the PowerSC product Standard Edition. This feature actually appeared in May 2012. Now also note that if you're a network guru, and I'm by no means anything like that, then you may come with some baggage, some expectations about what is involved in the firewall. And the Trusted Firewall we have in the virtual I/O server doesn't have many of the features you may be expecting. So perhaps we should really call it a trusted shortcut, and we're not expecting you to remove other firewalls in a computer center. But I had better explain that in more detail now. So here's my picture of what's going on. Here we have the great unwashed users out here on the cloud, and they're coming into the master firewall. This may be coming into your company or something. Then it's going to cross into the C and into the web server. The web server is going to collect some information to send it back, but it's got to activate an application server to collect some of the data. So the packet then goes out onto the VLAN, then it goes out to the physical network. The physical firewall decides, is this allowed? Yes, it is. So in it comes again, back across the VIO server and the C, back into the virtual network to the application server. So the application server then collects the information that you need, and it has to look up some database records. So the packet's now going to go across the VLAN here to the physical network to the physical firewall device. It will decide whether it's allowed or not, and it will come back over the physical network across the C to the virtual network to the database. The database then collects the data and sends it back in the same route back to the physical, back to the virtual, back to the application server. Now the application server says, I've got some user numbers in here. I should be outputting the usernames. So it's going to make another traverse back to the database, physical network, virtual network to the database to collect the names. Then it comes back across the virtual to the physical, the firewall, the physical, the virtual, back to the application server. And it may do this traversing back and forth here half a dozen times. So then eventually we got all the information. So now it's going to send the information back across the virtual, the C, the physical, the firewall, the physical, the virtual I/O server, C, the logical, back to the web server, and he can return the data to the user's screen. Now you can't help thinking that's an awful lot of network traffic. There's an awful lot of jumps down the network stack, and we're going virtual to physical and physical to virtual again and again and again, so that we can have the firewalls here monitoring who's talking to who. And you can't help thinking that maybe we should have some sort of mechanism of keeping these packets in the box and then making sure that we're still obeying these firewall rules. And this is where the Trusted Firewall comes into practice. Now I'm also told that the cost of these physical firewall devices tends to be related to how much traffic they're dealing with, and if you overburden them with lots and lots of packets, you may have to upgrade at expense these firewall physical devices to hit this networking limit. So I've added to my diagram now our trusted firewalls. These sit inside the virtual I/O server and does this shortcut of the network packets so we can avoid going out to the physical network and through the physical firewall devices. Perhaps we can save some physical firewall devices, we can cut down on those links, we can certainly stop the reduced latency and the physical bandwidth. And hopefully our transactions will actually run faster because of this. We're keeping all this network traffic within the power machine now, so we'll get quite a performance boost. We get a performance boost just because we don't have to run all those device drivers back out and back in again to the physical network. Before we go any further, I better highlight the fact that I haven't removed those physical firewall devices even from my diagram. Between the web server and the application server, there is typically 2, 3, maybe 4 different ports between these two logical partitions that will actually be used for the vast bulk of the traffic to run this application. And the same thing between the application server and the database server. It may just have 1 or 2 ports to actually do all the real work. Now when we're setting up the trusted firewall, it's those well-known bulk of the traffic ports and IP addresses that we want to run over the trusted firewall, to take the bulk of the work and to shortcut that so that it'll work faster. Now, if something strange is required on the database server, maybe somebody wants to send mail from it, or perhaps connect a printer to it, well, we're not going to take those somewhat rare ports and IP addresses and put those into the trusted firewall. We'll just allow those packets to go back up to the physical networks to be handled in the normal course of business. So we don't want to actually remove those physical firewalls, because it can do those odd packets and the unexpected workloads that we see on the network, and they can deal with them in terms of logging and alerting and producing stats for those. Okay, enough theory, let's get practical and look at the prerequisites. Well, first of all, we need the virtual I/O server 2.2.1.4 or later. That came out in April 2012 or thereabout. Because all of the trusted firewall is implemented in the virtual I/O server, any of the operating systems allowed in Power can benefit from the trusted firewall, so AOX, IBM I, and Linux on Power. Now, we've created a PowerSC wiki on the IBM developer work, so we have a lot of information to help you get started. But there is a red book, the Managing Security and Compliance in Cloud or Virtualized Data Center using IBM PowerSC. This came out in November 2012 and has all the information you really need, and I strongly recommend that is the first thing you go and read to pick up the skills in Trusted Firewall. Now, there's 5 stages of getting our firewall configured and up and running. Number 1 is we install onto the VIO server disk the actual Trusted Firewall software, and we're going to use SMTI install P as you'd expect. Number 2 is we load the device driver. It's called the Secure Virtual Machine, and we get that installed in our protocol stack. Then we switch that on with the VLAN TFW, VLAN Trusted Firewall command. Then the most of the work is going to be involved over here in number 4, where we define and manipulate the rules. Once we have all the file rules set up and created, then we push those into the device driver with the mkv filter command. So let's go through those 5 points in more detail. On the VO server, we log in as PAdmin and then OEM Setup M to get to the root user. You'll need your PowerSC 1.1.1 media, and we just do a SMTI install P. It has to be the Power Standard version, and we're looking for this thing called SVM, the Secure Virtual Machine. It takes a couple of seconds to install, so we won't waste any further time on it. Next, as the PAdmin user, we're going to initialize the SVM driver. The mk-svm does that. It doesn't give you any positive feedback that something happened, but you can use the lsdev command to go and find it and check that it's available. For reference only, we can remove this device in the protocol stack later if you want to with the rmdev command, as you can see. Next, then, we're going to start up the trusted firewall. There's a couple of options in here. The VLAN TFW command -S will start it up. Then you use the -D option. Now, a little word of warning in here. The first time you run it, if you do that just after it started, it won't report many statistics. It will go around looking at the VLANs that are available inside the machine, and that discovery can take a few seconds. So give it a minute or so, and then you'll see all the VLANs in your machine. It's a very useful list to confirm that the VLANs that you think you have are actually there and available. We can also use the VLAN FTW -Q command to let us know that the firewall status is up and running. Now, the rest of the trusted firewall is all down to the filter rules, and we're going to look at these in some detail so we can learn the syntax and the rules. I'll be giving you 5 examples that we can work through, and this will show most of the features that are useful. Now, I strongly recommend that you have a nice safe sandbox to experiment with the trusted firewall rules. If you have the external firewalls that allow the communication between VLANs, it can be very difficult to know when you put the trusted firewall shortcut on that it's actually using the shortcut rather than the external firewalls. So we're going to set up this sandbox that doesn't have the external firewalls connected to it, so that if we get packets between our networks, so between our logical partitions, we know that it's taking the trusted firewall shortcut. So first of all, I set up my machine with 3 logical partitions in a virtual I/O server. They're called red 2, 3 and 4, and the virtual I/O server is red VIO server 1. All set up, they're all on the same network, the 137 VLAN, and they can all communicate as normal, so I'm very happy that this all works. Then I'm going to make a few changes, making it ready for running with multiple VLANs and checking my firewall is running between them. Now I've added a few other things. So on the HMC I've added VLAN 100 and 200 for this particular Ethernet slot. And my red 2 I've changed it rather to VLAN 100, and on red 4 is VLAN 200. And on the C configuration on the VIO server I've added the VLAN 100 and 200 to this C so that it can deal with the packets coming in. Next, I learnt quite a lot at this stage because I didn't really understand this about networking. So this VLAN 100 and 200 are working without a gateway. They can't send packets out because there's nothing connected to those particular VLANs. This means that we can prove when we're moving packets between VLAN 100 and 200 that this is actually going over the trusted firewall. The reason why it won't send packets externally to red 2 and red 4 is because it can't find a MAC address for the gateway. For example, if you do a ping, it will just hang until it finds a gateway MAC address. So we need to fake these gateway MAC addresses. An example here is for red 4 to set the gateway to this, and we're going to use a random MAC address. I've actually just created a MAC address from the actual machine and added some random bits to it, and we're going to use the ARP command in here to make sure that it will actually try and forward packets to this MAC address even though it isn't there. Only then will the packets actually get to the virtual I/O server and can then flow over the trusted firewall. Once we've set this up, we find that I can't actually get to red 2 and red 4 over the network because there's no gateway. So I have to use the HMC vterms to communicate to these packets to actually try network operations and check whether the firewall is working. So here's my testing setup. At the top in here I have red VIO server 1. It's on the network, so I can use SSH to get to it. In here I'm going to start the firewall, set rules, and then see if I can get them to work properly. Down below I have red 2 and red 4. In this example in here I'm trying to do a telnet operation and that's failing, it's trying and can't get through. But over here I've got ping working, it's just started up because I've just put the ping rule in here and it activated it. The first thing you'll notice is that AIX takes about 20 minutes to boot for these logical partitions without a gateway. I think it's sending a packet for some legal or license reason, and eventually it times out and starts up. The quick fix for that is to switch off DNS, to remove any NFS. I did a NIM install so it was on NFS, and switch off the NIM client. Now you'll find that a reboot takes about 90 seconds, which is much more comfortable to handle. So these are all the filter commands. We're going to look at these: make, remove, list, change and generate. The first one, the make virtual filter, I guess is what it means, -u. This is the command that pushes the firewall rules from the ODM into the actual device driver stack and activates them. It's very easy to forget this. You make changes to the filter rules, you concentrate on all the details when you forget to do the push, and you still find that your filter isn't running. Eventually you remember, oh, I haven't actually pushed them, so they're not active. Next we have a remove vfilter command, -n all. This removes all the rules from the ODM, and it appears to also remove all the rules from the kernel. It's not actually documented, it just says remove. That is what we actually wanted to do. Now in this initial release there is a slight bug in here. You can remove a particular rule using the rule number, and we'll see the rule numbers as we list the rules. But that doesn't work. So what we have to do, and probably what we would do anyway, is that we remove all the filters, then we have a script that goes through creating all the filter rules, and then we push those rules into the device driver. Next we have a command list the virtual filters, and this is going to allow us to either look at the ODM set of rules, not necessarily active, or the -a gives us the active in use rules. So here's the list vfilter command. As we just started up, there's no rules, and it looks like this. There's in black there's a few bits and pieces which I don't think will appear in later versions. Perhaps they were used for testing or something. Then I got very excited that we have this filter rule in red full of zeros and -1s. And this looked to me like the rule that means the default position for a firewall is that no packets go between any VLANs or whatsoever. But then when I asked the developers, they said, no, actually this is because the ODM needs at least one rule in the database, and so they put this one in. In later releases they said they may actually just not show us this, and it would just look blank, and they'll ignore this first rule. Right, the next rule is the change filter rules, and I don't really see the point of this particular rule. It actually hurt my head to think about it. If you're going to script the rules, then you're going to remove them all and rerun your script to make them all. You can actually use this change vfilter command to change particular rules. The syntax is exactly the same as the next command we're going to look at, the generate vfilter command, but you also have to specify which rule you're actually wanting to change. So I won't cover that here. I'm just letting you know that it's available if you really want it. So here's the big one, the generate virtual filter, and there's lots of options, and it's fairly scary when you look at them all like that. So we're going to break this up and look at them, or pairs of them, 2 by 2. Alright then, let's break these out to the important ones first and work our way down. At the top we have the -v option, which is 4 or 6. This is IP version 4 or IP version 6, and as far as I can work out, most people are still using IP version 4. But 6 is available. The next one down is the deny or permit traffic. Now, by default, a firewall denies everything, so we're going to use the -a large P option to permit traffic. We will come across an instance where we want to do a deny when we're looking at ranges later on. Next we have the lowercase z and the uppercase z. Notice these sorts of pairs that come in like this. We'll see that further on as well. And the z's are for the VLAN source and the VLAN ID target. Next up then we have source and destination for the IP addresses. This is S and D. Then we have some more complicated things that allow us to restrict ourselves down to particular ports. You'll notice here we have the little p and the large P for the source port and the target port numbers. In AIX we can find the port numbers in etc. services, as you can see at the bottom. Most applications, if they're being installed and they're going to use specific ports, actually add their entries into etc. services. If not, you're going to have to look at your application vendor to supply the port numbers that it's actually using. Also here we have another flag, so the lowercase o matches the lowercase p, and usually we're going to use this one called equals, so we're going to say -o equal -p and the port number we actually want to use. And then we have the uppercase O and the uppercase P for the target ports. The other ones that say not equal are used for specific purposes and ranges. Finally, we're going to use the protocol definition to decide which of the protocols we're going to apply these rules to. So we have UDP and TCP/IP. We could apply any if you like, and the ICMP is used for that low-level network talking to itself type protocols. Normally, we don't deal with that level as a AIX systems administrator, but do note that ping is an ICMP type protocol, and so that's probably the one thing that we want to do. So let's learn these filter rules by a few simple examples. First one then is allowing anything between two VLANs. Now this doesn't actually make much sense. It means pretty low security. In fact, anything can go on between these two VLANs. It's more like what I would call a bridge operation. In fact, we don't even need two VLANs. But up the top here we have going to generate our filter -v4, so IP version 4, -a capital P, so permit, These Z and Z are the two VLANs involved. Then we're going to push this into the device driver and list the active filters. We have then a filter number 1, and as you can see it says source and destination 200. Now because this doesn't have any port numbers involved, it's also implied that the traffic can also go in the opposite direction. I've greyed out the options there that we haven't actually supplied and are just the basic allow anything. Here's our second example, anything between two IP addresses only. This is actually starting to do some security. Other IP addresses will not be able to talk to each other over this firewall. The options to start with are all essentially the same, and we have a source and destination IP addresses. Here are the IP addresses of my Red 2 and Red 4 LPARs. Again, we're listing out the details in here, and we can just see we have the VLANs as before, and the source and destination are the ones we expect. Again, because we haven't got port numbers in here, this allows the same traffic in the opposite direction between Red 4 and Red 2. Now here's our third example. Things are getting a bit more complicated in here. Now I know I'm using Telnet, but we're just trying to learn the rules rather than encourage you to use Telnet. Telnet is port 23, and we're going to allow Telnet between any IP address between these two VLANs. So again, at the front in here we have IP version 4 and permit, the two VLANs. If we go to the end here, we see we're using the TCP protocol with the -C option. Here's the port number 23, which is linked to Telnet. This is where I started learning things again that I wasn't aware of. The destination end has to be equal -O -P23, but the port that you're coming out of your server, your source server, can actually be any port, and in fact it will allocate the next available free port as you're leaving the machine. I didn't know that, so in this case we have to use -o any -p 0, and this just means you can use any port that you want to actually exit from the machine. And now that works, but now because we have port numbers in here, we have to have a second rule to allow a telnet operation in the opposite direction. We just put the same rule in. If we swap over the 100 and 200 up the top here, then that will give us a different direction going from the second VLAN to the first. Okay, here's example 4. Things are getting more complicated now. Again, we're using FTP, which is insecure, but it's a well-known network utility. It's port 21. We can see that in etc. services if you go looking. And now between the two VLANs, we're only allowing these two IP addresses, these two logical partitions or virtual machines to talk to each other. At the front it all looks the same. At the back it's the same as the Telnet example, except it's port 21 in this case. And now we've added the source and destination IP addresses. This means that just these two logical machines can actually talk to each other. Again, because we have port numbers in here, we need a second rule if you want to allow FTP in the opposite direction. As a complicating factor, I'm told that FTP is one of the oldest network utilities, and it actually uses two ports, one for control and one for data. But as most utilities do, if you specify one port, it will also connect the other one automatically for you, otherwise the FTP won't actually work. And again, the Trusted Firewall understands how to deal with this historic protocol and deals with it appropriately. Our final example is a nice easy one. Let's allow ping everywhere. So in this case we got, again, IP version 4, permit, the two VLANs and -C ICMP. I'm just covering this one because if you hadn't worked out that ping is an ICMP type protocol, then you wouldn't have actually ever worked this out. Let's cover the case of port ranges. Some applications allow a range of ports. In my little example here, 4000 to 4005. So how can we do that without needing to create a rule for every single port number in the range? Well, we can use the same commands as we've seen before, but we're going to use the target port number of greater than GT and 3999, so that means any port number 4000 or greater. And then we're going to use, this is the first case, we're going to use a deny, a minus a deny. Again, the destination greater than 4005. So my diagram in here, we're going to permit everything above 3999, and we're going to deny everything above 4005, so only the green numbers in that range are now allowed as possible destination port numbers. Now, we looked at various examples there. I want to encourage you not, though, to use the very simple rules, because allowing lots of things between VLANs is not very secure, although we can hide particular machines because there's no rules for them at all. We could limit only certain ports, but then we give quite a wide range of targets of IP addresses across the VLANs. But if we limit the ports, the host and the direction, now we're into very secure operation, and that drastically limits what the hacker can target to try and get between the two networks. Now, I have given this presentation about half a dozen times to a room full of network experts, and they tend to come up with the same sorts of questions every time, so I thought I'd answer those right now. What does the Trusted Firewall do with packets that are not allowed? Normally a firewall drops these packets. Well, these are passed on to the higher level external firewalls to deal with as normal. What if you have multiple Cs? Well, if you look at those rules, they apply to VLANs, so the rules apply to all Cs, not an individual C of the VIO server on which you're running the script full of rules. In the case of dual Cs in two VIO servers, you need to apply the same rules to each VIO server, so whichever is active will be using the same rules and avoiding the same network traffic. What if you use LPM, live partition mobility? Well, you should apply the rules to the target VIO server. Otherwise, when your logical partition arrives at the target VIO server, you're back to the all packets go to the external network mode, which of course is slower than using Trusted Firewall. It will, however, work fine. What happens when you delete all the rules to apply a new script full of rules? Well, you temporarily, all packets will go to the external firewall until you re-establish your Trusted Firewall rules. What about performance? Well, I have no performance data available. Always a problem with networking. There's so many different packet sizes and all this sort of thing. But it has to be faster, because you're just calling less device drivers. We're avoiding putting it onto the physical network, which involves copying the packets onto the adapters, and then the latency across the network and the time it will spend in the external firewall. So it can only be faster. And finally, what about the firewall logs, the firewall packet inspection, stats, hack alerts, and etc.? Well, yet again, this is not a full hardware device firewall. That's why we recommend you leave those in place to do these sorts of things. We're just using the Trusted Firewall shortcut to save a lot of work on the network, speed up the internal packets flying between the logical partitions. I better flag up a little problem we have in this initial release. I expect it to be fixed in the first update. We have to be very careful if you remove the C before removing the SVM, as it can result in system failure. Now, system here means the virtual I/O server, not the entire box. Just a little reminder of the commands we've seen already that will actually remove the SVC, and then you can change the C as normal. That's the end of our getting started with PowerSC Trusted Firewall shortcut. We haven't actually demonstrated anything here because it's very easy to set up and use. All the hard work is in the concepts, getting the good understanding of those firewall rules, and then building up your script so you cover what you want. Don't forget, if you haven't watched this from the AX Developer Works wiki, then you may be looking at it in lower resolution, and there's another 100 movies there for you to have a look at.